Today we are going to start with topic momentum. This topic is basically this is a complete chapter which is named as momentum, and it is also a short chapter like the moment we did in the last class. So basically, if we talk about momentum, so momentum is also a common word we use in our daily life. You also observe this word during the commentary in any sports or any cricket match or any football match, that the momentum of that player, momentum of the ball, momentum of the car. So basically, we all many time hear this word in our daily life. But what is the basic scientific concept behind this word, and what is the formula, and how to calculate the momentum, and any specific laws link over there? So today we are going to discuss about all these things, right? Okay, so first of all, if we want to write a definition for momentum, so basically momentum is a quantity of a matter, sorry, quantity of a motion, quantity of a motion in a body. Because we know that there are two types of state of a body. One is rest state, one is motion state. So when we are going to calculate the amount of motion, so if you want to calculate the quantity or amount of motion in a body, so that can be calculated by means of momentum, right? And how we can calculate the quantity of a motion in a body? By using the formula. And if we talk about the formula for momentum, so the
Mass
formula
into
will be,
velocity.
yes, you already know about the momentum.
Yes.
Okay. So basically the symbol we use for momentum is P. So P is equals to mv, a very basic formula for momentum. So that is not very difficult. And someone asks you to write the SI unit. So SI unit you may also write by using common SI units of other quantities, just like mass and velocity. We use kilograms for mass and meter per second for velocity. So kilogram meter per second is SI unit for momentum, right? So one more thing, let's suppose if this is a specific term, or this specific concept is basically related to the motion of a body or the motion state of a body. Let's suppose if we are talking about any rest object or any rest or body that is in a rest state, so there will be no quantity or there will be no amount of momentum over there, right? So it means that object at rest, it means zero momentum. So when solving the question, if you observe any object is at rest, so you need to know about it, that either we are going to use the concept of momentum over there or not, right? And if we talk about scalar and vector quantity, so what do you think is momentum is a scalar quantity or a vector quantity? Because scalar only contains magnitude and SI unit, and vector quantity contain a magnitude plus direction. So what do you think, that momentum will be a scalar quantity or a vector quantity? Vector quantity, okay. So basically momentum is a vector quantity, right? And we know that in vector quantity we need to find out the direction also. And according to the definition, according to the formula, we are not writing about any specific direction. So it means that when we are writing vector quantity, so it means that there must be some specific direction. So if we talk about the directions, so basically momentum can be either positive or it may be negative. And how it may be positive or negative, we will discuss that, how momentum is going to be positive or how it is going to be negative. So let's suppose if we talk about the direction, So first of all, it may be a positive momentum or a negative momentum, and let's see how it is possible. So let's suppose if we consider a tennis ball, let's suppose we are having a tennis ball and we throw this tennis ball towards the wall. Okay, up and right, nice. Negative down and left, okay. Okay, basically, when we are writing negative momentum, or we can say that the negative direction of momentum, and when we are writing the positive direction of momentum, so basically it depends upon the situation. It also depends upon the direction, that which directions we are going to consider about that specific object, right? So don't get confused that there must be some specific direction for negative, or there must be some specific direction for positive, because in exam they are not going to ask that define negative momentum, define positive momentum. So it happens like this. Let's suppose if there is a wall in front of a ball, and we throw this ball towards the wall. This is a wall. So first of all, the initial direction of ball is in forward. Ball is moving in forward direction. This is the initial direction of ball towards the wall, right? So let's suppose this is the initial movement of the ball towards the wall. So let's suppose if we consider this direction positive, right? It's up to you. If you are considering this direction negative, it's up to you. So the second direction when ball bounce back, so that direction will be opposite. Basically, the concept of positive and negative direction is like opposite directions. If someone is moving in forward direction and you are moving in the opposite direction, so that is the concept of positive and negative, just like the x-axis and y-axis. If we consider x-axis, so when we are moving towards right side of the graph, so we are getting positive x-axis, and we are when we are moving towards the left hand side on the graph, so we are getting negative x-axis, right? It depends upon only the direction, right? So let's suppose if we consider the motion of a ball, or the initial motion of the ball in forward direction, and let's suppose I'm considering this direction as a positive direction, right? Because this is the initial motion of a ball and it is moving towards the wall. After reflecting back from the wall, when this tennis ball bounce back from the wall, now ball is going to be bounced back from the wall in the opposite direction. So the direction of motion will be opposite this time, like this. So basically, a basic concept is we are getting opposite direction. So when we are getting opposite direction, so we just write negative. Basically, negative gives you the concept that there must be some value which is completely opposite to this one, right? That is the first direction of motion. Are you getting the concept? Let's suppose if wall is on the left hand side, right? If wall is on the left hand side and ball is moving towards left hand side, okay? So you may also consider that direction positive because that was your initial motion. So there is no hard and fast rule to always consider right hand side positive. It's up to you, because normally we also consider graph. In graph we consider positive side on right hand side or positive axis on right hand side. So that's why we consider right hand side as positive, left hand side as negative. Okay. But there is no specific or such rule that you always need to consider right hand side as a positive. It's up to you, but there is only a concept of change in direction, right? So basically it depends upon the quantity and it depends upon also on the direction. So we may write it as, let's suppose if we are going to talk about the change in momentum, because in many question in MCQs they ask about this question, that momentum will change, or what are the factors that will change the momentum of an object, like this. So you need to know about the factors, that how many factors are there that will change the direction or that will change the quantity of a momentum. So the very first thing is the object accelerates, because when we are talking about mass and velocity, so basically when one object is moving from one point to another point, so there will be a change in motion, or we can say that change in the position. And when you need to change the position, so you must speed up the object, or you must start from the rest state. So it means the object accelerates. So when object accelerates, so your momentum will change. Let's suppose if there is a footballer, and footballer is moving with around 15 meter per second speed, and suddenly it starts running very faster according to its previous speed, and now it is running with 25 meter per second. So basically when the speed of the footballer change, so that give you the concept of change in momentum also, because change or momentum depends upon mass and velocity. So if you increase the value of velocity, so your momentum will also increase, right? Because there are two factors, m and v. So m basically depends, or we can say that mass is directly proportional to momentum, velocity is also directly proportional to momentum. If we increase the mass, so momentum will also increase. If we increase the velocity, momentum will also increase, right? So when object accelerates or decelerate, in both condition, momentum will change. And the second thing is, that is already mentioned in the formula, if mass changes. Okay, mass changes means, let's suppose in shopping center or in any journal store, let's suppose we are moving some trolley on the floor, and someone is just adding products in your trolley or in your cart, right? So the quantity of mass is increasing, or the value of the mass is increasing product by product, right? So your trolley become heavier and heavier, since someone is adding products or someone is adding extra mass in your trolley. So eventually your speed will decrease, right? Because you are applying same force, but the trolley is now become heavier as compared to the initial stage. So that's why by increasing the mass, your momentum will also change. I'm not saying that momentum will increase. I'm only using word momentum will change. So change in momentum means your momentum will also decrease, or it may increase. So if we increase the mass, so momentum will also increase, right? Because mass of a specific body remains same, but if we are adding some extra mass to object or to any specific body, so your momentum will automatically changes, right? And the last thing is, that is related to direction. Changes direction. So these are some basic things. Those are related with momentum. Okay. So this formula is very simple, and if someone asks question related to the momentum, so that will be very easy for you to solve the question. But the most important question from this section is related to law of conservation of momentum, right? Because these are some basic definition or some basic concept, basic formula related to momentum. But if we want to talk about the law which is related to momentum, so let's talk about that. That is the most important part of this chapter, just like the principle of moment we discussed in our last chapter. There is also a law, we are also are having a formula. So this law is also like the same. So the name of the law is conservation of momentum. Conservation means it will remain same, or in simple words we can say that the total effect of the momentum will remain same before and after, right? Or before or after any motion of an body, right? Okay, so first of all, if we consider a basic definition, so the basic definition is, yes, that was very good. So momentum before and after collision was momentum before and after collision will remain the same. In isolated system, right? Okay, isolated system means there will be no effect of any external factor. So basically this isolated term means no external effect, no effect of force, no external effect like you are not going to add some extra mass, you are not going to add or increase the velocity or decrease the velocity like that. Okay, you may also write that that one of you already mentioned that external force is not going to act on it. So you may also write like this. Otherwise, you may write in an isolated system, momentum before and after collision will remain same, right? So let's suppose if object is moving in forward direction, or if we consider the example of a snooker or any two footballs, this is object number one, this is object number two. So one is moving towards right, second one is moving towards left, and after some time both will collide with each other. This, and after collision they will move in the opposite direction. Yes. So initially when they are moving towards each other, so that is the condition of before collision. After collision will be like this. Okay, now if we talk about the formula, so formula will be like this. So formula we are going to use over here. Before collision, now let's suppose there are two bodies, right? So we need to write their masses because mass remains same. So m1 remains m1, m2 remains m2, but their velocity will change, right? So we need to write about their velocities. So let's suppose the initial velocity for object one, that is m1, we are using u1, and we are using u2 for their initial speeds, right? These are initial speed or initial velocity. And same goes for the second body. We will get V1 and V2. It represents final speed or final velocity. So the momentum before collision will be equal to the sum of their individual momentum. That will be like U plus U2. And what will be the value of the final momentum after collision?
M1 V1 plus M2 V2.
Yeah. So that is very simple, right? Just like the principle of moment. So combining these factors, because according to the definition or the statement, momentum before and after collision remains same. So final statement will be like m1 u1 plus m2 u2 be equal to m1 v1 plus m2 2. So this is our final equation for because let's suppose if we consider uh, example of a snooker. So when we are going to strike a white ball, so initially white ball is also at rest, and if white ball is going to hit a red ball, so red ball is also at rest state. But when we strike a white ball, so basically white ball is in motion but red ball is in rest state, right? And when white ball strikes or collides with the red ball, so both balls will start moving in different direction. So basically, the momentum is going to be transferred from the white ball to the red ball. So the velocity of white ball will decrease after collision, and the velocity of the red ball will increase. And if we are going to count the total momentum, so we combine the momentum of white ball and red ball. So we will get the same value as the initial velocity and mass of white ball, right? Just like if there are three people and they have to pay a bill of 1000. So let's suppose one of them contributes 500 and two of them contributes 300 and 200. So your amount of bill remains same, your contribution will be different, right? So same goes for.
Sir,
Hmm,
I have a question.
yes.
Just like when the object is at rest, the momentum is zero, right? So
Yes.
when it's in equilibrium, like the forces are acting on it, but it's balanced,
Yes.
the momentum is still zero.
Yes. The body which is at rest, so its momentum will still zero. Let's suppose if we again consider the same example, so the momentum of red ball initially is zero. Only the momentum of white ball was present over there before collision. And after collision, momentum of white ball plus momentum of red ball, we will get the final momentum. Okay.
No, I wanted to ask that
Hmm.
when the object is in equilibrium, like when, for
Okay.
example, during
Okay.
skydiving in the
Yes.
middle part.
Basically, that is related to forces. We will also discuss in the forces, but for journal, you need to remember that if you are talking about equilibrium state, so all forces must balance, like either body is at rest, right? According to Newton third law, one force is acting downward, like the weight of a body, and there will be a reaction force of the table. But object is still in rest state, right? And if you are moving with a constant speed, if car is moving with a constant speed, so all forward, or we can say that the all forces which are moving in or acting in forward direction, so there are also some forces which all are acting in the opposite direction, so both of them are balanced. That's why body is moving with a constant speed. So in that condition, we also say that a body is in equilibrium state. There are two categories, basically static and dynamic. So dynamic is the constant when body is moving with a constant speed. So that state is known as dynamic equilibrium. And when body is still at rest state, so that is known as static equilibrium, right?
Okay.
We will discuss it also in the topic or in the chapter of forces, right? Because there is a concept of stability, a type of equilibrium, because these topics not going to be asked in your exam, but you need to know about the concept, because sometime it was written equilibrium, so you need to know that what is the difference between equilibrium and rest, just like we discussed in our last class, right? So if in skydiving, when someone jumps from its initial position, so after some time when object starts moving with constant speed, that is known as terminal speed. So during terminal speed, the diver or skydiver is in equilibrium state, because all forces acting on a body is are balanced, right? All forces acting in downward direction and all forces acting in the opposite direction are equal and opposite to each other, so they balance each other. So in that state, we can say that skydiver is in equilibrium state.
So is it counted as zero momentum or not?
No, in equilibrium state, it is not compulsory that body is having some momentum or not, because momentum just counts the quantity of a motion, right?
Oh,
Okay, because in this formula or in whole concept of momentum, we are not writing about forces, right? So our main concern is related to the velocity, because mass, every object have some mass, so mass will never be zero. Velocity will be equal to zero. So our main concern is only related to the direction and the velocity, because mass remains same in every situation, right?
okay, thank you.
Okay, any other confusion? Okay, if everything was clear, so you may join me again with the same link, then we will start solving the question of momentum, right? Because those students who are doing O levels, so this topic is new for them, because this topic was not included before 2023 examination, but in IGCSE it was already included. So I already have a worksheet related to the momentum, because we need to practice this conservation of momentum formula, because there is a problem in solving the direction, because we can easily solve the calculation part, but we got confused in the direction. So to practice them, you may join me back, then we will start solving the question. So you will get the concept how to apply this formula in our situations, right?